Okay, I'm going to make this a part 2 because I'm going to start right here with using the Cramer's rule to solve a system of 3 equations with 3 unknowns. I had a group come in, so I wanted to go ahead and pause. So I want to go ahead and use the fact that we know that we're going to use x is going to equal to the d of x that we talked about before on the last problem, divided by the determinant. Y is going to be d of y divided by the determinant, and now z is going to also be d of z divided by the determinant. And so to find each of these amounts, what we want to do, we're going to go ahead and just find, let's start off by finding, since d is common on each one of my variables, when I solve for that, I'm going to go ahead and find what d is. Now the determinant is going to be the x, the y, and the z column without what it's equal to. So in other words, I'm going to find the determinant. Remember, it has to be a square matrix. So it'll be 2, 4, 5, and then we'll have 2, negative 1, negative 2, and then I'm going to have 3, 1, and 6. And then remember, because it is square determinant and it's a 3 by 3, I can do the trick where I repeat this column, the first column and the second column. So I'll do that, negative 1 and negative 2. Remember, if you continue on in math and you want to find one that's a 4 by 4, you'll have to go ahead and use the system that we talked about earlier. But for your test, you have to only know how to do a 3 by 3 and a 2 by 2 determinant. Then we're going to go ahead and multiply diagonally, going down. So I'll have these 3 terms that I'm going to multiply together. So I'm going to start off with, I'll have 2 times negative 1 times 6 plus, then I'm going to go down here, I'll have 2 times 1 times 5 plus my last one will be then 3 times 4 times negative 2. Then we're going to subtract then the sum of the products going upward and diagonal. And that was kind of a funky little. So I will have then 5 times negative 1 times 3, then plus negative 2 times 1 times 2, and then plus the last one of 6 times 4 times 2. So when I finish this out, I'm just going to go ahead and work this out. So in other words, I'll have 2 times negative 1 times 6, that's going to be a negative 12. I'll have 2 times 5, so plus 10, minus 24. Then I'm going to subtract then the summation of here, so I'm going to go ahead and take 5 times negative 1 times 3, or negative 15. I'll have minus 4 plus 48. And so to finish that out, I'll have then negative 26 minus 29, and that's going to equal negative 55. Now I'm going to go ahead and set up my how to find d of x and d of y and d of z. So when I find the top part of my fraction, again, which is what I'm going to put, I'm going to make a fraction of d of x over d. I need to find d of x, and that is going to be a 3 by 3 matrix. But this time I'm going to take wherever my x column, and I'm going to replace it with what I call the constant. And so the 10, negative 5, and 1 will replace the 2, 4, and 5. So I'm going to go 10, negative 5, and 1. Then I'm going to keep my matrix exactly the same. 2, negative 1, negative 2, 3, 1, and then 6. Remember, I'm going to repeat my 2 rows. So I'm going to go 10, negative 5, 1, and then 2, negative 1, and 2. And then I'm going to do the same thing I did before. I'm going to go ahead and work this one out, but then I'm going to break and I'm going to jump ahead. So remember, we're going to do diagonals here. So this is going to be then when I multiply, I'm going to go ahead and multiply 10 times negative 1 times 6, so that's going to end up being negative 60. I'm going to go 2 times 1 times 1, so it's going to be plus 2. And then I'm going to also do the last one, which is 3 times negative 5 times 2, which is going to be then, 3, I should have a negative 2. Yes, I didn't repeat that, so that will be then a positive 30. Minus, and this time I'm going to go diagonally going up. 1, 2, and then 3. So the first one I'll have then a minus 3, because I'll have 3 times negative 1 times 3. I'm going to add negative 2 times 1 times 10, so it's going to actually be a plus a minus 20. And then the last one, I'll again go 6 times negative 5 times 2, and that's going to be either plus a negative 60 or just minus 60. To finish it out, I should have negative 28 minus a minus 83, and then that together will make it positive, so I have a positive 55. I'm going to go ahead and set up my d of y and my d of z. And in this case, I'm going to replace now my y column with my constant. So my x's will stay the same, so I'll have 2, 4, and 5, but now my y column will be 10, negative 5, and 1, and then I go back to z's, which is going to be 3, 1, and 6. Remember, I'm going to repeat the 2, 4, and 5, and the 10, negative 5, and 1. And then I'll find the determinant with that. I'm going to set up my z column. So again, now this time I'm going to replace my z's with the 10, negative 5, and 1. So I start with my x's as 2, 4, and 5, 2, negative 1, and negative 2, but then I'm going to have 10, negative 5, and 1, and then I'll repeat my two columns, 2, 4, and 5, and then 2, negative 1, and negative 2. I'm going to go ahead and pause for a second, and I'm going to go ahead and finish that out so that you can just see, you can double check the work.